Space is vast. It is filled with stars, planets, and galaxies. But space is also filled with asteroids. They orbit the sun. Most asteroids are harmless. They reside in the asteroid belt. Some come close to Earth. These are near-Earth objects, or NEOs. NEOs are of particular interest. Even a small asteroid can cause significant damage. A large asteroid impact is thought to have contributed to the dinosaurs' extinction. The threat of an asteroid impact remains a real possibility today. It's like a cosmic bowling game, and Earth is one of the pins. We need to track these asteroids. We need to understand them. Our survival might depend on it. Asteroids come in different sizes. Some are as small as cars, others are as large as cities. The size of an asteroid dictates the level of threat it poses. A small asteroid might burn up in Earth's atmosphere. It would create a dazzling fireball, nothing more. A larger asteroid could cause regional devastation. Imagine a massive explosion, shock waves, and tsunamis. The largest asteroids, those exceeding a kilometer in diameter, have the potential to cause global catastrophe. These are the planet killers, thankfully much rarer than their smaller counterparts. The impact of such an asteroid would release an unimaginable amount of energy. It would trigger widespread fires, earthquakes, and volcanic eruptions. The dust and debris thrown into the atmosphere would block sunlight, plunging Earth into a long period of darkness and cold. This impact winter would devastate agriculture and ecosystems worldwide. It's a sobering thought, but a necessary one. We can't ignore these potential threats from space. For centuries, humans were oblivious to the dangers lurking in the cosmos. We gazed at the stars, unaware of the celestial projectiles that could obliterate our planet. But times have changed. We are no longer passive observers of the universe. We have developed the technology to detect and track asteroids. We are beginning to understand the risks they pose. We are even starting to explore ways to deflect asteroids that might be on a collision course with Earth. This awareness, this proactive approach, is crucial to our long-term survival. We are part of a cosmic dance, a delicate balance of celestial bodies in motion. Understanding the movements of our cosmic neighbors, especially the potentially hazardous ones, is paramount. By studying asteroids, we gain a deeper appreciation for the fragility of our own planet. We also develop the knowledge and tools to potentially protect ourselves from a catastrophic impact in the future. Remember those sci-fi movies where Earth is threatened by a giant asteroid? Turns out there's some truth to fiction. Protecting our planet from asteroid impacts is a real concern. Luckily, we're not alone in this endeavor. Enter NASA's Jet Propulsion Laboratory, or JPL. Located in sunny California, JPL is a hub for space exploration. But JPL isn't just about sending robots to Mars. They also play a crucial role in planetary defense. Think of them as Earth's first line of defense against cosmic threats. One of JPL's key missions? Tracking asteroids. Using powerful telescopes and advanced algorithms, JPL scientists scan the skies looking for any space rocks that might pose a danger to Earth. They don't just look for any asteroid, they focus on NEOs, those that come uncomfortably close to Earth's orbit. It's like playing cosmic detective, except the stakes are much higher. Eyes on the skies. Tracking asteroids is no easy feat. It's like trying to spot a firefly in a fireworks display. But JPL has a few tricks up its sleeve. They use a network of ground-based telescopes strategically located around the globe. These telescopes are equipped with high-resolution cameras capable of detecting even faint objects in the vastness of space. But it's not just about seeing the asteroids, it's about understanding their movements. JPL scientists use complex mathematical models to calculate the trajectories of these space rocks. They determine whether an asteroid will pose a threat to Earth even decades into the future. This early detection is crucial. It gives us time to prepare to potentially deflect an asteroid before it becomes a danger. Cosmic bookkeeping. Imagine trying to keep track of every grain of sand on a beach. That's kind of what JPL does with asteroids. They maintain a massive database. a cosmic catalog of all known NEOs. Each entry contains vital information: the asteroid's size, its orbit, and its potential threat level. This database is constantly updated as new asteroids are discovered and their orbits are refined. JPL makes this information publicly available. Anyone with an internet connection can browse the database and see the asteroids that are whizzing past our planet. This transparency is important. It allows scientists around the world to collaborate and contribute to planetary defense efforts. It also helps to raise public awareness about the very real threat of asteroid impacts. Space Guard, Guardians of Earth. JPL's efforts are part of a larger international collaboration called Space Guard. This program, initiated in the 1990s, brings together scientists, engineers, and policymakers from around the world. Their goal is simple: to find and track potentially hazardous asteroids and to develop strategies for mitigating the risks they pose. Space Guard is not just a reactive program. It's also about proactive planning. Scientists are actively researching methods for deflecting asteroids. These methods range from kinetic impactors, basically hitting the asteroid with a spacecraft, to gravity tractors, using a spacecraft's gravity to nudge the asteroid off course. Space Guard represents a global effort to protect our planet from a common threat. It's a testament to human ingenuity and our ability to come together to address challenges that affect us all. It's about ensuring that the dinosaur's fate doesn't become our own. Now that we know about JPL's crucial role in tracking asteroids, let's meet some of these space rocks up close. Some asteroids are famous, like Apophis, named after the Egyptian god of chaos. Then there's Bennu, target of NASA's OSIRIS-REx mission. This mission collected samples from Bennu's surface, which scientists are eagerly studying. And let's not forget about Tutatis, a weirdly shaped asteroid that resembles a cosmic peanut. Every encounter with an asteroid teaches us more about these celestial wanderers. Apophis, named after the ancient Egyptian deity of chaos, certainly lived up to its name when it was first discovered in 2004. Initial calculations suggested a small but significant chance of the asteroid colliding with Earth in 2029. The news understandably caused a stir, but further observations and refined calculations thankfully ruled out the impact scenario. Phew! But Apophis remains an object of interest for astronomers. See, on April 13, 2029, Apophis will make an incredibly close approach to Earth, coming within just 19,000 miles of our planet's surface. That's closer than some satellites. While it won't hit us, this close shave will be a spectacular opportunity for scientists to study Apophis in detail. They'll use telescopes around the world to observe its shape, composition, and even its rotation. This close encounter will provide valuable data for refining asteroid tracking models and improving our understanding of these celestial objects. Unlike Apophis, Bennu is much smaller, measuring just over 1,600 feet in diameter. But size isn't everything. Bennu is a rare B-type asteroid, believed to be remnants of the early solar system, preserving the building blocks of planets like Earth. NASA's OSIRIS-REx mission collected a sample in 2020 and returned it to Earth in 2023. Scientists are now analyzing it for clues about the early solar system and the origins of life. Remember that cosmic peanut we mentioned earlier? That's Tutatis, an asteroid with one of the most unusual shapes ever observed. It's classified as a contact binary, meaning it's actually two smaller asteroids that are touching each other, held together by their weak gravity. Tutatis is also notable for its chaotic rotation. Unlike most asteroids that spin on a relatively stable axis, Tutatis tumbles through space like a poorly thrown football. This chaotic rotation makes it difficult to predict its precise trajectory far into the future. But don't worry, Tutatis, despite its close approaches to Earth, is not considered a significant threat. Its orbit is well studied, and scientists are confident it won't pose a danger to our planet for the foreseeable future. However, Tutatis serves as a reminder that asteroids come in all shapes and sizes, and their movements can be unpredictable. It's a cosmic wild card, keeping astronomers on their toes. While the thought of a major asteroid impact is enough to keep anyone awake at night, it's important to remember that these events are incredibly rare. Earth has been around for billions of years, and we've only experienced a handful of significant impacts. However, that doesn't mean we're off the hook. Smaller asteroids, those measuring a few meters to tens of meters in diameter, enter Earth's atmosphere more frequently. These events, while not globally catastrophic, can still cause localized damage. Remember the Chelyabinsk meteor that exploded over Russia in 2013? That was a relatively small asteroid, only about 20 meters in diameter, but it released the energy equivalent to about 400 to 500 kilotons of TNT, injuring over 1,000 people and damaging thousands of buildings. The Chelyabinsk event served as a stark reminder that even small asteroids can pose a threat, and it highlighted the importance of continued asteroid detection and tracking efforts. So, how likely is it that an asteroid will actually hit Earth? It's a question that often pops up, fueled by disaster movies and sensational headlines. Thankfully, the answer is not very likely, at least not in our lifetime. Think of it this way. Earth is like a small target in the vast cosmic shooting range. While there are millions of asteroids out there, the chances of one actually hitting us are astronomically small. Scientists use a statistical scale called the Torino scale to assess the risk of an asteroid impact. The scale ranges from 0 to 10, with 0 representing no hazard and 10 indicating a certain collision with global consequences. The good news is that most asteroids we discover fall into the 0 or 1 category, meaning they pose no significant threat. In fact, no known asteroid currently has a rating above 4 on the Torino scale. But what if, despite the odds, an asteroid does hit Earth? What would happen? The consequences of an asteroid impact depend on several factors: the size of the asteroid, its composition, its speed, and its angle of impact. A small asteroid, say a few meters in diameter, would likely burn up in the atmosphere, creating a spectacular fireball but causing minimal damage on the ground. A larger asteroid, perhaps tens of meters in diameter, could explode in the atmosphere, releasing the energy equivalent to a nuclear bomb. This would create a powerful shockwave, potentially shattering windows, damaging buildings, and causing injuries over a wide area. The largest asteroids, those exceeding a kilometer in diameter, are thankfully much rarer. But if one were to hit Earth, it would be a global catastrophe, triggering widespread fires, earthquakes, tsunamis, and an impact winter that could last for years. To better understand the potential damage of an asteroid impact, scientists use another scale, the Richter scale, commonly used for earthquakes. However, the energy released by an asteroid impact can be orders of magnitude greater than even the most powerful earthquakes. For instance, the Chelyabinsk meteor, which exploded over Russia in 2013, released energy equivalent to a magnitude 4.5 earthquake, even though the asteroid itself was relatively small. Now imagine an asteroid 100 times larger. Such an impact would release energy equivalent to a magnitude 8 or 9 earthquake, causing devastation over a much wider area. And if an asteroid the size of the one that wiped out the dinosaurs were to hit Earth today, well, let's just say it wouldn't be good news for humanity. The good news is that we're not sitting ducks. Thanks to the tireless efforts of organizations like JPL and the SpaceGuard program, we're getting better at detecting and tracking asteroids. The more asteroids we discover, the better we can calculate their orbits and predict their future paths. This early warning system is crucial. It gives us time to prepare, to potentially deflect an asteroid before it becomes a threat. Scientists are actively researching various asteroid deflection methods, from kinetic impactors to gravity tractors to even using lasers to nudge an asteroid off course. These methods, while still in the early stages of development, offer hope that we might one day be able to protect ourselves from a catastrophic impact. Cosmic preparedness. While the probability of a major asteroid impact in our lifetime is low, it's not zero. And just like we prepare for other natural disasters like earthquakes and hurricanes, it's prudent to be prepared for the possibility of an asteroid impact. This preparedness involves continued investment in asteroid detection and tracking programs, research and development of asteroid deflection technologies, and public education about the risks and potential mitigation strategies. It also involves international cooperation. Asteroid impacts are a global threat, and addressing them effectively requires collaborative efforts from nations around the world. By working together, sharing information, and pooling resources, we can significantly reduce the risks posed by these celestial wanderers. In essence, cosmic preparedness is not about living in fear of the unknown, but about embracing knowledge, fostering innovation, and ensuring the long-term survival of our species. After all, we're all crewmates on Spaceship Earth, and it's our collective responsibility to keep our vessels safe from cosmic hazards. Guardians of tomorrow. We stand at a pivotal point in human history. For millennia, we gazed upon the cosmos with a sense of wonder and awe, unaware of the potential dangers lurking in the celestial tapestry. But our understanding of the universe has evolved dramatically. We've gone from passive observers to active participants, unraveling the mysteries of the cosmos and developing the tools to not only explore but also protect our planet. The responsibility now falls upon us, the current generation, to become the guardians of tomorrow. We are the inheritors of a remarkable legacy, a legacy built upon the tireless efforts of scientists, engineers, and visionaries who dared to dream of reaching for the stars. It is now our duty to carry that torch forward, to ensure that future generations inherit a world where the threat of asteroid impacts is not a distant fear, but a challenge we have learned to manage and overcome. In the face of cosmic threats, knowledge is our most powerful weapon. The more we understand about asteroids, their composition, their trajectories, and their potential impact, the better equipped we are to mitigate the risks they pose. Our ability to detect and track asteroids has improved dramatically in recent decades thanks to advancements in telescope technology, computing power, and international collaboration. But we cannot afford to rest on our laurels. Continued investment in asteroid research, both in terms of ground-based and space-based observation programs, is essential to maintaining and enhancing our planetary defense capabilities. The more we know about our cosmic neighborhood, the safer we become. Protecting our planet from asteroid impacts is not merely a scientific endeavor. It's an investment in our collective future. The resources dedicated to planetary defense, while significant, pale in comparison to the potential costs of a major impact, both in terms of human life and economic devastation. Moreover, the technologies developed for asteroid detection and deflection have applications that extend far beyond planetary defense. Advancements in space-based observation, spacecraft propulsion, and laser technology have the potential to revolutionize fields such as telecommunications, resource exploration, and even climate monitoring. Investing in planetary defense is therefore not just about protecting ourselves from a specific threat, but about fostering innovation and driving technological advancements that benefit all of humanity. The threat of asteroid impacts compels us to adopt a cosmic perspective, to view our planet not as an isolated oasis, but as an integral part of a vast and dynamic solar system. This perspective fosters a sense of interconnectedness, a recognition that our actions or inaction have consequences that extend far beyond our immediate surroundings. It also underscores the importance of international cooperation. Asteroid impacts are a global threat, and addressing them effectively requires a coordinated global response. By sharing data, pooling resources and working together towards a common goal, we can transcend national boundaries and build a safer future for all humankind. The challenges of planetary defense remind us that we are, at our core, one species sharing a common destiny on this fragile planet we call home. As we look to the future, we draw inspiration from past generations. They overcame challenges and built civilizations. Asteroid impacts are daunting but not insurmountable. We have the tools and collective will to protect our planet. The journey requires vigilance, commitment, and global cooperation. Embrace our role as guardians of our planet. Create a future where the cosmos inspires a shared destiny. A future worth striving for, where humanity's ingenuity lights the way forward, ensuring our story continues for generations to come.